I forgot to turn on, sure that we're on camera. So while this is coming down, really quickly, so I found my final exams for Salt Lake Community College. Now, the only thing is, there's actually 25 questions. The first 10 are multiple choice, which is a no-no at UVU. There's not going to be any multiple choice because they have a rule against multiple choice. So, is it 15?
That's what it says on the study packet they gave us.
Oh, okay, 15 then. So anyway, there's 25 on Salt Lake Community College. It'll give you a little bit more. There'll also be some multiple choice, which you won't get. But anyway, it'll be, so that's what we're going to do tomorrow. So I will come tomorrow. I'm going to try to be here. I don't know if I can be here for 10 minutes early. I'll try to be here as soon as I can. I'll pass them out immediately, unless you, because today's going to be a question and answer day. Okay? So anyway, so we'll do that tomorrow. And then on Thursday, I'm pretty sure I can be here 10 minutes early. So I'm going to start passing them out right when I get here. And then you can have theoretically the whole 2 hours if you're here 10 minutes early. Okay? So there's your incentive on Thursday. Okay? All right. So what questions do you have from the final exam review that you would like to ask me? And I didn't print one out. Caitlin always has questions, right?
Oh, yes, I have loads of questions on.
Okay.
Do you have a copy on there?
I don't have a copy, but I can borrow yours.
Okay.
You have a question?
I'm looking for one.
Okay, so I'm just confused, like on this page, like, because I know it said it passes the horizontal line test, but I don't know if those do. Because I don't know if those are parabolas or if it's just the.
All right, so this is from the review. This is number 4. And it says the graph is given. Does it have inverse? And if yes, sketch the inverse. Okay, so I'm just going to be, it looks like if I go 1, 2, 3, and this looks like it's about 1, it looks a little bit curvy here. Okay, and then it looks like I've got a, if that's 2, and that's 1, I'm going to try to draw this as accurately as I can, and then something like 7, and this is 5. Okay, so I'm going to put these points in here because those are going to be important points to consider. And this goes out here to -5. Okay? So the first question is, no, that's the way it is. That's horrible to see. Let's keep, oh, we're focusing. Okay, good. All right, so the graph is given. Does it have an inverse? How do we know if it has an inverse?
Doesn't have to be 1 to 1.
It has to be 1 to 1. Is this 1 to 1?
No,
No.
No? Why not?
because that weird curve at the end, right? It's the vertical line test that we're looking for, right? It's a
Horizontal.
Is it the vertical line test or the horizontal line
The
test?
horizontal is vertical, isn't it?
So if it passes the
It would be
horizontal.
horizontal because you're wanting it to
So vote? Who
Who
says it's the horizontal line test? 1, 2, 3, 4, 5, 6, 7. Who says it's the vertical line test?
Yeah. Let's go.
Okay. It's the horizontal line test. What does the vertical line test tell you?
If it's a function.
If it's a function. Is it a function? Yes, it is a function. Is it 1 to 1?
No.
Okay, so if I do my horizontal line test, how many times does it touch? It only touches 1 time. Is it 1 to 1?
Yes.
Yes.
Okay.
Sure.
Yes.
Yes, it is.
Okay.
Okay? So does it have an inverse?
Yes.
So then yes, it does.
Yes, it has an inverse.
Yes.
Okay? Now we need to draw the inverse. And that's why I made a specific point. It's not so clear on the graph there, but I made it very clear on my graph, and that's why I wanted to make sure these points were clear. Okay? So an inverse function is symmetric about
X, Y equals
the
1.
y equals x line. So if I draw a y equals x line here, okay? Hopefully that's good enough, okay? It's got to be symmetric about that, okay? Now, those 4 points I put on there are key to helping you draw this correctly. What should I do about that?
So you just mirror those ones, right?
We need to mirror those, okay? So let's pick this point first. What is the mirror of that?
So is that 2, 1 you have?
That would be 2, 1. Okay? What's the mirror of this?
7, 5.
5.
5, 7.
I wish this was drawn better. It's drawn terribly. Okay, that's 5, and this is going to be 6, 7. Okay? This is really, you guys have a nice graph, unlike mine, but I had to improvise. So this 5, 7, sorry, this is 7, 5, becomes 5, 7. 5, 7, so it's going to be right here. Okay? So now these are going to connect. Okay? What does this point become? This is negative 3, 1, so it becomes 1. Sorry. Yeah, so this is negative 3, 1, so it becomes 1, negative 3. So 1, negative 3. Okay? So therefore, this is going to go back down to here. It would look better if I had real graph paper. And then this point becomes, it's a negative 5. What point is that? Oh, I didn't draw it very well. Let's assume that's the point there. Okay?
-2.
So if this is the point negative 5, negative 2, then it becomes negative 2, negative 5. Negative 2, negative 5. So I've got a curvy thing like that. Okay? So yes, function, and the red is the inverse function. And it would look better on, you guys at least have sort of graph paper. Okay?
So no matter what, if it passes the horizontal line test, it's going to have an inverse.
Mhm. If it passes the horizontal line test, it will have an inverse. Okay?
Do 10.
Number 10? All right, this is going to be hard. Graph the rational function f of x equals x squared plus x minus 2 over x cubed minus x squared minus 6x. So it says show all asymptotes, intercepts, and whole, if any. Okay? This one is yours. So how do we do that? Okay, we should find the vertical asymptotes first. Where would we find the vertical asymptotes?
So we have to factor the bottom first.
Have to factor the bottom, right? Okay, the bottom is factors into, I can pull out an x, right? I'm left with x squared minus x minus 6, right? And then what? factored into x minus 3 and x plus 2. Okay?
Yeah.
So I've got vertical asymptotes where?
Zero.
X equals 0.
X.
3 and negative 2.
3, x equals negative 2. Okay? So 1, 2, 3, 1, 2. So I've got a vertical asymptote here. Boom. Boom. Okay? So those are for sure. Okay? Now we need to figure out what?
Should we factor the top two to see if there's a hole?
Maybe that might be useful. How would there be a hole?
If there was plus 2 on top.
Okay.
Plus 2 on.
We factor the top, we're going to factor it into x, 2, 1, right? Plus, minus. Do I have a hole?
Yes.
I do have a hole because this is the same as that. So I've got a hole at x equals 2. Okay? X equals negative 2, rather.
So does that mean you don't have an asymptote at negative 2 or?
So here's what I will say about that. Different people feel differently about this. I think the book does not put this as an asymptote. I'd rather leave it there and just know that you know that it's a hole. And I'm the one who gets to grade this. Okay? So my way's right. Some people would not put this here. I would rather you left it there. Okay? Just know that we do have a hole here. Okay?
Don't we mark a point as a hole? Or is that?
Well, we'll get to it in a minute. We'll talk about how to get there. But what we do want to do is we do have a hole at x equals minus 2. What about your horizontal and your oblique? We need to figure those out, right?
Degree.
What's your degree of the numerator?
It's less than the degree of the denominator.
The degree of the numerator and the degree of the denominator is 3, right? So therefore,
It's the oblique. Well, not oblique now. Your hole is at y equals x.
No. That means it's a positive rise, right?
a positive right?
That's a different step.
Because doesn't that, wouldn't it look like the 1 over x asymptote?
Yeah, so basically we've got x squared over x. If x cubed, if I simplify that, that simplifies to 1 over x, which when it gets really big, goes to,
When it goes really big?
when x gets really big, what happens to this fraction?
Oh, it gets really tiny.
It's smaller.
It gets very close to 0, right? So I've got a horizontal asymptote where
X equals
y equals 0. Okay, so I've got this here.
Before we continue, can we review those rules? So I'm looking at them, I remember there was an exception, so the numerator is less than the degree of the denominator.
The degree of the numerator is less than the degree of the denominator. So what you do is it's going to be y equals 0. If it was greater than the degree of the denominator or equal to, what would you do?
So oblique, right?
You'd do synthetic division and find out if it was a slant.
Yeah, that makes sense. Oh, yeah, I remember that.
Okay? All right. So, so I've got this here. Now, could it cross? Because remember, occasionally we can cross this one. We can never cross a vertical. That's why it's a hole. But we could cross a horizontal, right? My guess is if it's going to cross, it's going to cross in this area. It won't cross in either of those areas. Okay? How do we prove whether or not it crosses or not?
Plug it in, right?
Plug it in.
We said, yeah, so we plug this in to here. So 0 equals x, I'm going to leave it this way, x minus 1, x plus 2, x minus 3, right? So those are going to cancel, right? And then what? This is a good one. They did a really good
Marked
job on
as
this one.
hard.
I know, it is marked as hard. That's good. This is hard.
So.
We might have a cross and a hole. How do we know? What do I do next?
So.
So,
You have to put the X back in.
Actually, it wouldn't matter, but maybe I should look at it. That's all right.
yeah, did we FOIL it back? We gotta simplify.
Or does
right?
it not matter?
It doesn't matter,
Really
because
not matter.
even if you didn't worry about crossing that out, in fact, I kind of want to keep it in. You're going to multiply by the denominator, right? So that's going to still be 0.
Oh, right.
So I've got 0 equals x plus 2, x minus 1, right?
Okay.
So x equals 2 or positive 1. Okay, now the problem is, what do you notice here? Oh, x equals positive 2. No, x equals negative 2. Yeah, that's negative 2. I got a problem here because I know it can't cross. Okay, so I've got a hole at x equals negative 2. Well, if I stick in f of negative 2 equals negative 2 plus 2, well, no, I'm going to do it this way. Negative 2 squared plus negative 2 minus 2 over negative 2 cubed minus negative 2 squared minus 6 times negative 2. Okay? So f of negative 2 equals negative 2 squared is 4 minus 4, which is 0, right? And then the denominator, as long as it's not 0, doesn't matter. This is going to give me negative 8. That's positive 4, but that's negative. And that's positive 12. Oh, I got 0 over 0. Dang it. I was hoping that would help me. Okay, so really, let's take the simplified fraction. X minus 1 over x times x minus 3. Okay, we're going to take the simplified fraction at this point. Okay, negative 2 minus 1 over negative 2 times negative 2 minus 3. Okay, that's negative 3 over negative 2 minus 3 is negative 5 times negative 2 is positive 10. Okay, so that tells you where the hole is. The hole is f is negative 2, y is negative 3/10. Okay, so about right there you've got a hole. Okay. Now the other number here, we say it can cross there, correct? So if I go back to here, and I guess I can use the simplified one, f of 1 equals 1 minus 1 over 1 times 1 minus 3 is 0 over negative 2, which is 0, correct? So x equals 1, y equals 0, it crosses. X equals 1, y equals 0. It's going to cross right there. This was a good one. Okay. All right, so I found all my asymptotes. I found an intercept. The intercept is at 1, 0. The hole is at negative 2, 3/10. My asymptotes I've listed here. I guess if we have a hole, if they're asking for holes, I guess there's no reason to keep that there. So I've got 2 vertical asymptotes and a horizontal. Okay? Now, what?
Now we fill in the areas, right?
You want
So
to
we
fill
gotta
the
check
areas.
each section.
So the question is, I have a feeling it's probably going to go like this. I'm not sure what's going to happen here, if it's going to get close to here or close to there. We'll see. We'll find out. Okay, so what do we do now? Plug in f of, say, what?
Negative 3.
Negative 3. Let's find out what happens. Negative 3 squared plus negative 3 minus 2 all over negative 3 cubed minus negative 3 squared minus 6 times negative 3. Okay? So this becomes 9 minus 5, which equals 4. This becomes 27. That becomes positive minus 9 plus 18. So 27 minus 9 is 18, and 18 is 36. It becomes 1/9. Okay? So what's happening here is 1/9 is about, let's see, is less than, so it's going to get close to, so it's going to stay close to here. Okay? Over here now, we need to do pick a point, right? F of, should we shut that door?
4?
F of 4, in this case, equals 4 squared plus 4 minus 2 over 4 cubed minus 4 squared minus 6 times 4. So 4 squared is 16 plus 4 is 20 minus 2 is 18 over 4 times 4 is 16 times 4 is 64 minus 16 minus 24. So that's 40. 64 minus 40 is 24. 18 over 24. So at this point, that's a positive number. So at f of 1, 2, 3, 4, I've got a positive number. Let's see, if we divide those by 3, that's 6, 8, 3/4. So we're positive, so we're roughly about right here. So clearly it's got to go something like that. Okay? That was a goodie. Who got it right? Just me?
Yeah, looks like.
But just now?
Did you know how to, who feels confident that they could have done that one?
Not great. Started.
So, there's only ever going to be 2 of those, right, on the graph? There's not going to be in the other quadrants.
So normally, well, because of the whole thing's got a little bit more weird. We still picked a point here. We got the point, what was it? 1/9? -3, 1/9. So we picked a point here. That was already given to us, and then we picked a point here. So you still need to pick a point in each of the 3 vertical regions. You have Asa Christian?
No.
Okay. Julia?
Yes, coach.
Yes, coach, I like that. Bryn?
Yeah.
Cool. Okay, what you got now?
Oh, there was, I know which one we have to do. There's no set paper.
Also, on a side note, did you see our fan?
Did I see what?
Did you see our fan? The second left?
Oh, Mario. I did not do that. Shall I respond?
Yeah, which one?
Oh, Margaret. Okay, can we do?
All right. What else you got?
Can we do number 13? I just get so confused about graphing the logs and stuff. That
Oh, the log functions,
yeah.
which are awesome.
That's weird, yeah.
All right. Oh, you know what? You didn't tell me that we didn't get that on there. And Marco didn't say that we missed all that. Okay? That was all the work that we just did. Okay?
Yeah.
All right. Okay, this is number 13.
Yes. I mean, technically, we can do any of this.
13. Use transformations of y equals the log base 2 of x to graph g of x equals 1 plus log base 2 of x plus 4. So A says find intercepts, B says asymptotes, C says domain and range, and D says graph. Why do they always put that at the end?
They just don't know your trick.
I know, what do they think?
What would
Okay. All right, so what do you think? Should we graph, what does log of 2 of x look like?
It looks like the inverse of 2x.
It looks like the inverse of y equals 2 to the x. What does that look like?
Well, it's an exponential, so then it like flips it. I don't know. I have a hard time with this. I just start plugging in points because I get so confused.
Starts low, ends high. Is there any particular, so this graph here, is there any important points I should remember?
Like it moves or to the left or right?
Well, we're not moving anything with this, right?
Yeah,
Oh, are
0,
we
1,
doing the
right?
original? Sorry.
Is it 0, 1?
Yes.
Yes.
No,
No, it's 1, 0.
it's 1, 0.
Yeah, it's flipped, and then you get some.
Where's my asymptote?
Oh, because it's a lot.
Your asymptote is on the y.
The y-axis. So I can asymptote here, and it should look something like this, right? That's what this looks like. Okay? Now, let's talk about what does this 1 do to me?
Moves it. I get confused. Does it move it up 1 or does it move it to the right 1?
Should we vote? Okay, she gave us 2 choices. Does it, who says it moves? Oops. Who says it moves up 1? 1, 2, 3, 4, 5. Who says it moves it to the right 1? That's not much of the majority. I think the majority didn't answer that question. But yes, it's going to move this point up 1.
Okay.
Okay? So we've now moved this point up 1. Correct? Has anything changed to my asymptote?
No.
Not yet. Okay? What does this plus 4 do to me?
Moves you to the
Moves
left
it to the
4.
left.
It's going to move this point to the left, and it's also going to move my asymptote to the left, right?
Okay. So your
So my asymptote was here. It's going to move it to the left. 1, 2, 3, 4. My new asymptote is right there. This is my new spot. Correct? Okay, my new important point. So it's not there anymore. So it's going to look something like this. Now, it didn't, okay, so find intercepts. We're going to have to figure out what that point is. And we're also going to have to figure out what that point is, right? How do we find those? Those are good. Okay, so your asymptote, we can answer that question. Where's your asymptote?
Y equals -5.
What'd you say?
No, it's -4.
What would be -4? Yeah.
Did you say y?
I said X.
X equals
-4.
-4. Okay, so that's done. Intercepts are going to be a little bit harder to find. What about your domain and your range? Can I do that now?
Yes.
Domain is
X is greater than.
Everything above
X has to be
-4.
greater
Yeah.
than zero.
greater than -4. Can I put an equals on there?
No.
No. Your range is
Yeah.
y is an element of all real numbers. Okay? And if you want, I'll full credit on those. Make sure you include an x and a y on those. Okay? Now, if you want to write, is there another way to write these?
So it says using interval notation.
If we use interval notation, how would I do the domain?
Parentheses, negative infinity.
Negative infinity?
Wait, just give me one.
negative
I
4
was thinking of all the numbers inside.
to positive infinity, right? And in set notation, this would be, y is an element of
Negative infinity to
negative infinity to positive infinity. Okay, so that's done. The graph is basically done. We just need to make sure we have the intercepts. How do we solve those? How do we find those intercepts? Because I might have drawn that way too high. I'll just change the scale, that'll be fine, right? Okay. So set the equation equal to 0, correct? So 0 equals 1 plus log base 2 of x plus 4. How do I solve that? Move the 1 over, so subtract 1. Negative 1 equals log base 2 of x
would we
plus
do the change of base
4.
20 on it, put it in our calculator? Or would we-
Maybe.
Oh, wait, never mind.
Then what?
Anti-log?
We do the anti-log, right? Another way to think of that is to exponentiate both sides, right? So 2 to the minus 1 is 1/2 equals, that's going to go away, x plus 4. And then what?
Subtract 4.
Subtract 4. And x equals
3.5.
negative 3.5, right? Which is right where I drew that. Amazing. Okay? So that point is negative 3.5, 0. So I found this point. Now,
Now we have to plug in.
now we need to
0
find the one.
first.
Now we need to find this one, right?
Yeah.
How do we find that point?
We're gonna plug in
Wait, so the x
Zero,
correct is at negative 3.5?
Do what?
So which one did you just plug in?
the x.
X is negative 3.5, which is right there. And y is 0.
So we shifted it, but
So now we need to figure out what this point is.
So that part, we're gonna make x 0, right?
X is 0 this time. So now, so I'm going to get y equals 1 plus log base 2 of
4.
4, right? 0 plus 4, right? 0 plus 4.
So then you would do 1 plus log 4 over log 2.
1 plus log base 2 of 4. What's log base 2 of 4?
Change of base.
No, you should be able to do this
Oh,
without the
yeah,
change
it's
of base
just-
formula.
2.
2,
How'd you get that?
because 2 to the squared is 4.
Yeah, so I could rewrite this as 1 log base 2 of 2 squared, right? Which means I can pull this 2 out front. 1 plus 2, and what's the log base 2 of 2? 1, so that's going to go away. So I'm going to get y equals 3. Which is 1, 2, 3, right where I drew it. How about that? Okay? So my other intercept is 0, 3. Who needs a calculator? Yes.
I'm a little confused still, because on the, the unshifted formula, it's 1, 0 as the y or x intercept. And so the shifts, those aren't.
So remember, yeah, so you're asking about the shift. So we shifted it up 1 due to this one, and then we
okay.
shifted this point 4 this way because of that.
Yeah, okay.
So this is no, what it was an intercept, it's no longer an intercept
Yeah.
anymore. Okay. Victor, you gonna ace this?
Yep.
You better. You better, or I'll kick your butt. Okay, 100. You gonna ace?
Oh, yeah.
100%? No.
If I did, then I'd be like,
Okay, what else you got?
17.
17.
yeah.
Here, we'll try to get the rest of the board so I don't ruin it. All right. This is number 17. Solve e to the 2x plus 5e to the x minus 6 equals 0. Please give exact answers, which means what?
Don't put it in your
Don't put it in your calculator. Okay? What do you think, Jonathan?
What are we trying to
So you gotta solve it.
figure out? What x is? Is that what it is?
Yeah, we gotta solve for x. Something with natural logs, yes, but not yet.
Do we have to do this, right?
U-substitution, thank you, Angel. Okay, so what do we do now? What do I substitute? Well, what do I let u equal? U to the x. So therefore, u squared equals e to the 2x. Isn't that nice? Okay, so this now becomes u squared, right? Plus 5u minus 6, which is really easy to factor. Okay?
U plus 6.
U plus 6, u minus 1 equals 0. Okay, so therefore, e to the x
Plus 6.
So here, let's do it this way. U equals minus 6 or u equals positive 1. Do you agree with that? Okay. And there, now we'll substitute back. And so e to the x equals minus 6 or e to the x. E to the x equals 1. Okay. So how do we solve that?
So now we do the natural logs.
Now we do the natural log, right? Because when we do the natural log of both sides, I can pull this out front, right? But what's the natural log of negative 6?
It's not real, it's negative.
It's not a real number,
So
correct?
that's the final answer.
So that's undefined, right? Undefined. So this one, there's no answer to that. Okay. But this one we can do x equals the ln of 1, right? What's the ln of 1?
Specific.
Huh?
Isn't it just-
What?
Wait,
Either
what
0 or
is
1.
it?
What's the ln of what?
1 over 0.
It's gonna be
Is it
E,
0?
right?
Is anything to the
0.
0 power is
It's
1?
0.
You had to cheat with your calculator. You should know that one without your calculator. The ln of 1 is 0.
Yeah.
What's the log of 1?
0.
What's the log base pi of 1?
0.
Now, the log of 1 is always 0. Always, always, always. Doesn't matter what the base is. Okay? So x equals 0. That's your only answer.
Okay, I got one we can do.
Okay?
Can we do number 7? This is the rational 0 theorem.
The rational zeros theorem. Okay? So it's number 7.
It's a really long problem, so you might want to.
Oh, this is hard too.
Yeah.
P of x equals 2x to the 6th. I think I'm around the room. Minus x to the 5th. Minus 13x to the 4th. Plus 13x cubed. Plus 19x squared. Minus 32x. I really should have put this here. Plus 12. I barely fit on there. Okay? So part A says use the rational zeros theorem to find all possible roots. Part B says to sketch, there's no way we're going to fit all this in here. Part C, oh, sorry, that's part C. C says sketch the graph. You know me, I always like to do it with
Can you erase the other part?
intercepts and behavior. Part B says factor. Now we need to factor before we can sketch. Okay? So how do we start this?
So do we have to find?
We're definitely going to take up the whole board on this problem, probably.
Yeah, so don't we have to find how many changes there are in signs, so you'll find out how many positive, negative, zeros there are?
Do you have, okay, so that's Descartes' rule of signs. Do you have to do that?
Well, I
I'm
just know
going to say
there's a
you
lot of
don't, you don't ever have to do that, although it is helpful. And I don't,
We can write the
personally,
P's and Q's first.
personally, I don't care about the Descartes rule of signs. Especially on this, I probably wouldn't even do it. Okay?
So we have to do the P's
Although
and Q's.
the positive's easy, if you want to do the positive.
Yeah.
Because we're just counting changes of signs, right?
Yeah, so there's
So I've
12
got,
changes.
looking at the positive, I've got 1 change, 2 changes, 3 changes, 4 changes, right?
So there's
So I've got 4 or 2 or 0 positive roots. Okay? The negative roots is kind of a hassle. But at most, I'm going to have
2 or 0? Because it has to all add up to that 6, right?
well, at
So
most,
that's
I'm going to have, yeah, it has to add up to 6. 2,
or 0.
normally you would subtract 2, and if I did this properly, it could have 1 or 0. Normally, I probably wouldn't worry about that, but I didn't go through it, and you can. It could be 1 or 0, or it could be 2 or 0. Probably going to be 2 or 0. Okay? So, but that's not the rational zeros, right?
Right, so we have to do the P's and Q's.
We need to do our
So-
P's and Q's. P's and Q's, right? What are my P's and Q's?
Okay, so, the Q is the 12 out there, or is it the P is the 12? I always like mess these up, I mix them up.
P is the last one.
Okay, so.
Actually, is this correct? If I only have 2 positives, I could have 4 negatives, right?
Yeah.
So that really, but it'll either be 4 and 2, or it'll be 2 and 4. Or it could, or 0. Yeah, I don't think you're gonna have an odd number of negatives, because it's an even degree, right?
Yeah.
Okay. All right, P's and Q's.
So you do, it's 12, so it's plus or minus 1,
Plus or minus 1,
2,
plus or
plus
minus
or minus
2.
3, 4, 6, 12. All of them plus or minus.
Okay.
And then the Q's is plus or minus 1 and 2.
All right, so that wasn't too bad. So all the possible roots are all of these divided by all of those, correct? So if I were to list them out,
So you
so
have,
all possibles, which is what they're asking for, all possible roots, okay?
yeah.
So I'm gonna have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And then I get to do the fractions, right?
1/2 and 3.
Plus or minus 1/2,
And
2 halves is 1, 3 halves,
And then the rest cancel out.
and 4 halves is 2, are listed, 6 halves is 3, 12 halves is 6. Okay, so I should have 1, 2, 3, 4, 5, 6, 7, 8 possible answers for this. Okay? All right, now we need to factor it, right? So how would we do that?
So, since there's, So we have to do the, what's it called, synthetic division.
Synthetic division would be the easiest way to do this, okay?
Yeah.
What number do you want to pick first?
Let's do 1.
1. I always like to start with the easy ones, right?
Yeah.
Okay.
Oh,
So this becomes 2, negative 1,
negative 13, 13, 19, negative 32, and 12.
32, and 12.
Okay, so you bring the 2 down to start with.
Okay, 2 times 1,
Is 2,
2,
and then 1,
1,
and then
1,
negative 12,
12,
and then negative 12, 1, 1, 18, or sorry, that's 20, my bad.
okay?
And then that's 20 again, and then it becomes negative 12,
That was
so then it's
lucky.
0.
All right, so we have a fact, this is a factor, right? So one of the factors is, I'm going to pull this over here now. Sorry, people at home can't see. But I've got a factor of x minus 1, and I'm left with what?
You're left with 2x
2x to the fifth.
Plus x to the fourth minus 12x to the third plus x squared plus 20x minus 12.
Okay, now, we can kind of look at this. So I've got, as far as changes in sign, no change, 1 change, still 2 changes, 3 changes, right? So at most 3 or 1 or 0 positives, right?
So we have to keep going through and doing it.
You don't have to, but it could be helpful.
Because isn't it 6 terms now? So can't you factor by grouping, or is that not allowed? It's only when there's 4 terms.
If you can figure your way to factor by grouping, you're welcome to it, but I don't see a way. Okay, so now, have my P's and Q's really changed at all? No, because I still got a 12 and I still have a 2. So P's and Q's still didn't change. Could I reuse this 1 possibly?
Maybe.
I could, yeah. So we haven't eliminated anything. The one thing that I would say here, as we go back to here, just one thing to kind of pay attention here. If these had all been positive, or then what does that tell us?
There's no.
It has to be.
It's not there.
And this would have been an upper limit.
Oh,
If these had alternated signs, they almost do. If that was, if this, oh no, still. But if they alternated signs, what would that indicate about this? That would be the lower limit, okay? We don't have anything here, so we can't do anything on limits there. But just something to keep in mind, okay? All right, so what do you want to try next?
Let's do 12. Wow.
12 creates gigantic numbers.
That's true. Let's try 2.
Yeah, I always start with small numbers.
Yeah.
How about negative
and-
1?
Want to try 2?
Yeah.
2 seems
But it
like a
has
good
to
choice.
gigantic numbers.
So I've got 2, 1, negative 12, 1, 20, negative 12.
So bring down the 2,
Okay?
then it's 4, that's 5, and then that's 10, negative 2, negative 4, that's negative 3, so then that's negative 6, that's 14, and then that's 28, which does not equal 0, so that's
Okay, good mark. Okay? So now we're going to try.
Negative 1.
Let's try negative 2 while we're on it. We can go to negative 1 next too, but. So the nice thing about whiteboard is you can just erase everything. Okay? 2,
negative 4,
negative 4,
negative 3,
negative 3,
positive 6,
6,
negative 6,
negative 6,
positive 12, that's 13. And then that's
Negative
negative 26. So then that's negative 6. And that's a positive 12.
All right, so I got a nice big fat 0. Okay, so now I'm left with x minus 1. What is this?
X plus 2.
X plus 2, and then this represents 2x to the,
Wait, 2x?
Two X
Oh,
to
never mind,
the
sorry.
fourth
2x to
power
the fourth plus.
minus 3x cubed minus 6x squared plus 13x minus 6, right? Okay, so what's the nice thing about this? I can now throw out the 12. 12 ain't gonna work. Positive or negative.
And the 4 is taken out, right?
The 4 is taken out? Why is the 4 taken out?
No, over here on the P's, isn't the 4 taken out as well? 'Cause
Oh, the 4 because, yeah, 4 is not worth trying over here because 4 is not a factor of 6. Okay, so that's good. So we've been able to eliminate a few now, okay? All right, what are we trying next?
-1.
-1. And this becomes
Becomes 2,
Two,
negative 3,
three,
negative 6,
negative
13.
6, 13, negative 6. Okay,
Bring down 2,
2,
negative 2,
negative 2,
negative 5.
negative 5,
5,
negative
1,
negative
1,
1,
14,
14,
14.
negative 14. That didn't work. Okay, let's try positive 1.
Oh, we can do it again, that's right.
Yeah, we can redo it. Okay,
Okay, so bring down the 2,
2,
it's positive 2,
2,
negative 1,
negative 1,
negative 1 again,
negative 1,
negative 7,
negative 7,
then negative 7 again. And that makes it 6.
6. Ooh, that worked. Okay, so now this becomes x minus 1 squared times x plus 2, and I'm left with
X to
2x
yeah, 2x
to the third power minus x squared
minus
minus
7x
7x
plus 6.
plus 6. Darn, I was hoping I could do some factor by grouping, but nope. Okay, so now what?
Is 3 out? Because it's on factors.
3 is a factor of 6.
Oh, that's all that matters. Just
On the p's, yeah.
yeah, let's do 3.
On the 3? Okay, so we've got 3, 2,
One.
negative 1, negative 7, and 6. Okay?
Okay, bring down the 2.
2,
6,
6,
5,
5,
15.
15,
That equals 8.
8,
And then that's
24. And now this is 30. Okay, what do you notice about that?
All
It's
positive.
It's all positive, so 3 is an upper limit, right? Okay? So 3 is an upper limit. 3 is upper limit. So I can therefore get rid of 6, right? 6 is definitely not a factor. Okay?
So should we try positive 2?
Let's try negative 3 while we're at it. Let's see if we can get a lower limit while we're at it. Okay?
So bring down 2,
2,
negative 6, negative 7, positive 21. So that becomes 14. And then
42, and that's going to be negative 36. What do we know about that? Negative 3 is a lower limit.
so then we can get rid of that.
Okay? I probably shouldn't have crossed out the whole thing, but I did. Okay, so it's got to be between 1. So 3 we've tried now. So it's got to be between 1 and 2 now. Okay?
Would it be gross to try?
We can try the halves and the other things too, and maybe we will. Okay? But there's no use trying 6, that's for staying sure. Okay, so what do you want to try now? 2. 2?
Yeah, positive.
Okay?
So bring down to 2,
2,
4,
4,
3,
positive 3,
and then that's 6,
6,
negative 1,
negative 1,
and then that's negative 2.
negative 2, 4, let's try negative 2, 2,
Negative 4,
negative 4,
negative 5,
negative 5,
positive 10,
positive 10,
and then it's 3, so then it's negative 6.
3, negative 6, 9. Okay, so this becomes x plus 2. Okay, so we've now factored in this to x minus 1 squared, x plus 2 squared, and I'm left with 2x minus 5, 2x squared minus 5x plus 3.
So now, is that factorable?
Is that factorable?
Actually, no, it's not. Wait.
Yeah, it is.
Oh, yeah, because the 2 and the 3 is the 6.
2x, x, 3, 1. That's negative 6 plus 1, negative 5x. Okay, so there we are. So this is what we've now factored it into. Okay, so what we could have tried negative 1/2, and we could, wait, didn't we say that 3 didn't work?
Yeah. Negative 3 didn't work.
Positive 3 was the upper limit. We didn't get positive 3 to work either. Did I make a mistake? Well, whatever.
Well, whatever.
Why didn't positive 3 work? That should have worked.
Half hour down the drain.
Anyway, doesn't matter. We got there eventually. What did I do to make a mistake there? Anyway, whatever. I must have made a mistake. 3 should have worked. Okay, so now what? Now we can graph, right?
Yeah. Let's try to do a quick graph. Didn't work.
Okay. So you have,
Isn't this negative 6 plus 1 is negative 5? 1 times negative. Oh, you know what? That doesn't. I did do that wrong. Yeah, because this is negative 3. That's positive. So it doesn't work. Okay, so what do you do at this point?
you have to do the quadratic.
Quadratic formula, right?
Let's read some gross rate.
Okay, so negative b plus or minus the square root of b squared times 4 times a times c all over 2 times a. Okay? So negative 5 plus or minus the square root of 25 minus 4 times 2 is 8 times 3 is 24. All over 4. Negative 5 plus or minus the square root of 1 over 4. So negative 5 plus 1 is negative 4, so that's negative 1. Negative 5 minus 4, so that's 3/2. That's negative 3/2. Okay, so this factors into essentially, we could have factored that. What did we do wrong? Whatever, it doesn't matter. X minus 1 squared, x plus 2 squared, x plus 1, and x plus 2/2, or 3x minus 2, either way. That's what it factors into. Okay? So, how do we graph it?
Just gonna throw it on there.
Oh, I erased all that, that's all right. Okay? So I've got a 0 at positive 1, negative 2, negative 1, and negative 3/2. Wow, that's kind of weird.
Okay, and
Okay, what's the end behavior?
so you have to figure out multiplicities of it.
End behavior was x to the 6th, right?
Yeah.
So it's going to start high. We're going to get to negative 2. What's going to happen? It's going to pop up, right? It's going to touch. We're going to get to 3/2, negative 3/2.
Gonna cross.
It's going to cross. We're going to get to negative 1. Sorry,
It's
this
cross
negative 1 is
again.
going to cross again.
And it's gonna give
We're
a little
going to
kiss
get
to that
positive
last
1. And it's going to look like that.
Also, I think that's wrong.
What's wrong?
It shouldn't be negative 1 and negative 3/2 at the end. They should be
Negative
positive.
5 plus 1 is negative 4.
Negative 5,
Over
negative
4 is negative 1.
It's a
Negative
positive
5
5
minus 1 is negative 6. Negative 6 over 4 is negative 3/2.
Yeah, that
It's
math
a
works, but
positive
your
5.
signs are off. It should be a positive 5.
Yeah, because it's negative b, and it was a negative 5 starting out, so negative and negative is positive. You had it right at the beginning.
Oh, and somehow I didn't
Yeah.
transfer. Oh, so this should be that positive 5. Okay. 5 plus 1 is 6, so that's positive 3/2. 5 minus 1 is 4. Oh, these are both. So those are both in the wrong spot. So, yeah, well, positive 1. Okay, let's draw it again. Okay, so positive 1, negative 2, negative 1, and negative 3/2, right? Okay, so we're coming along here. We get to negative 2, and it touches. We get to here, it crosses. We get to negative 1,
Crosses.
it crosses, and that's what it looks like.
Okay, sweet.
All right, so just for sticking around today, should I say this on camera or should I not? Here, we'll end class. But if you didn't come to class, guess what? You missed out on something for not sticking around.